It's a big month for a little planet.
Mars is going to have company soon in the form of various spacecraft hurled its way from Earth.
Each of those craft has its own story, and we'll give you the lowdown.
Before we get to that, though, we'd like to remind you that Big Picture Science counts on you, our listeners, for financial support.
And that support is now incentivized thanks to Patreon. Go to patreon.com/bigpicturescience and sign up now. It's quick, it's easy, and it grants you early access to an ad-free version of the new episode each week.
Not only that, but if you donate just $5 a month, you'll also get access to exclusive bonus material, which includes extended interviews and occasional musings about mysterious phenomena.
Sounds mysterious. Well, give more each month, and you get more, like the opportunity to ask questions or hear your name in the credits of our podcast.
But the bottom line is you help keep this radio show and podcast going. Just head over to patreon.com/bigpicturescience and join us. We appreciate your support.
Thanks. Our interest in Mars is part of a tale of two worlds. Shortly after their birth, 4.5 billion years ago, conditions on the red planet and on Earth were pretty similar. But they soon went their separate ways. Earth became carpeted with life and Mars became cold and dry. So what happened? Well, NASA has mounted a daring mission to Mars, hoping to find out. And there'll be company. Spacecraft from 2 other nations will be in the neighborhood.
Well, I think all this activity shows that we're living in a space age. It's not just something that we're dreaming about for the future, but it's something that's happening now. And this month, February, we're actually seeing 3 missions from 3 different countries arriving at the planet Mars.
So what does it mean that Mars is the focus of new international missions? And what might these efforts reveal about what happened to its lakes and oceans? Was there ever life on the planet? I'm Seth Shostak.
I'm Molly Bentley. This is Big Picture Science, produced at the SETI Institute. In this episode, Mars will be a new place to find hope, perseverance, and ingenuity. Those are the names of some of the orbiters and rovers and the first helicopter that will be arriving this month to explore the planet. It's shaping up to be a red planet traffic jam, and we'll talk about it with the science lead from the Emirates Mars Mission, a NASA engineer with a knack for thin atmosphere flight, and a science journalist. It's Mars Attracts.
This month, on a planet far, far away, about 35 million miles away, that is, America will land a new rover on Mars, and 2 other countries will make history by sending their first spacecraft to the planet. China and the United Arab Emirates will be the 5th and 6th nations to send hardware Marsward. Can you name the other nations whose spacecraft have visited Mars? Now hold on to your guesses. We'll give you answers in a moment.
I have an idea what they are, but only because I was preparing for the show. Well, meanwhile, what would it be like to tread the Martian surface? Well, when Hollywood depicted that in the movie The Martian, we learned about a travel destination that would not win any points for hospitality.
I have no way to contact NASA, and even if I could, it's going to be 4 years until a manned mission can reach me. And I'm in a hab designed to last 31 days. If the oxygenator breaks, I'm going to suffocate. If the water reclaimer breaks, I'll die of thirst. If the hab breaches, I'm just going to kind of implode. And if by some miracle none of that happens, eventually I'm going to run out of food.
Dry, brutally cold, with a thin atmosphere, and home to planet-wide dust storms. But Mars wasn't always like this.
To the best of our knowledge, in the past, Mars was much warmer and wetter.
Now, that sounds more like a place hospitable to life.
We think there could have been life on Mars, and even today, there may be conditions for microbial life, so very simple life to exist on Mars. And if not, there might at least be evidence that there was past life on Mars.
Checking that possibility will be the NASA rover Perseverance. It will mark the 15th Mars mission for the agency. China and the United Arab Emirates will field, respectively, the Tianwen-1 probe and the Hope orbiter to become the 5th and 6th countries to visit the planet. We asked you to name the other governments that have sent hardware, and here's the answer.
So the Soviet Union, India, Europe, and also Japan attempted a mission to Mars, but it ran out of fuel on the way. I'm Sarah Cruddas, and I'm a space journalist, TV host, and author.
Sarah, for more than 4 billion years, our little ruddy buddy over there, the next planet over to the outside, Mars, had no visitors. It just sat there in the silence of space. Nothing was changing. Nothing really happened very much. But now that's about to change. Sure, Mars is far away, but it's going to get some visitors. So, what's going on? Why all of a sudden this activity?
Well, I think all this activity shows that we're living in a space age. It's not just something that we're dreaming about for the future, but it's something that's happening now. And this month, February, we're actually seeing 3 missions from 3 different countries arriving at the planet Mars. So you've got a US NASA mission, you've got a mission from the UAE, and you've also got a Chinese mission as well, which will orbit the red planet and then send a lander to Mars later in the year.
Is it just coincidence that they're all arriving at Mars at the same time? I mean, is there some sort of party?
Well, it feels like a coincidence, doesn't it? But obviously there was a good launch opportunity last summer, which enabled the positioning to be, correct to these missions to actually get to Mars. But I think what we're really seeing is that when we started exploring space, it was just about these 2 superpowers, the USA and the Soviet Union, and they were trying to do big things well. And I always think of Mars as being more of an American planet and Venus being more of a Soviet planet in terms of exploration. But space was very limited in terms of the nations that could access space. But what we're seeing now in the 21st century is that space exploration is no longer about 2 superpowers. So we're seeing many more nations developing the capabilities to explore beyond Earth. And where is more fascinating than the planet Mars?
Well, we should go into that. Why is it so fascinating? I mean, do you lie awake at night thinking about Mars and how fascinating it is? I mean, what is it about Mars?
Well, don't you lie awake all night thinking about how fascinating
Mars is?
Well, I
do, but I didn't figure anybody else did.
Well, we all do. How can you... I think, for the history of humanity, humans have looked up at the night sky. They've been able to see Mars, this red star in the night, so-called star in the night sky. But it was something that we could just look at and then dream about. And then if you look at throughout history, people started thinking, could there be life on Mars? I think there was the tale of the channels or canales, and then there was some confusion as to whether there was actually the potential for life on Mars. And even when we started first exploring Mars, people thought there might be life there. And I think the reason Mars is so exciting is because at the moment, the only life we know for certain that exists is here on Earth. We've only got one sample of life in this gigantic universe that we are a part of. And going to Mars and exploring Mars is really the next step, not only in terms of expanding where humanity can go. You really want to explore Venus, which is the closest planet to us, and Mars is the next best option. But it's also the next step in trying to answer those really profound questions, such as, where did we come from? Where did all life on Earth come from? Are we alone in the universe? And is there life elsewhere in the solar system or in the universe? And Mars has the potential to answer that question, because we know in the past, or we think in the past, that Mars was once much warmer and wetter. It could have had the conditions for life. It could still have microbial life today, but we're only going to be able to answer those questions by exploring Mars and by exploring it as much as possible.
So, Sarah, if you were to have visited Mars 4 billion years ago, and you were somewhat younger, as was I, although I was still not young, but if we'd gone to Mars 4.5 billion years ago, they would have looked pretty much the way the Earth looked 4.5 billion years ago, with oceans and a thick atmosphere and all that sort of thing. And yet Mars doesn't look anything like that now, and the Earth has, remained habitable. We're inhabiting it. What went wrong with Mars? Well,
we don't quite know, but we don't know why Mars ended up red and dead, so to speak, and the Earth ended up blue and flush with life. So by finding out, one of the reasons we explore, it's not only about our origins, where do we come from, or are we alone in the universe, but we also explore because we want to find out our destiny in terms of where is life on Earth going, where is humanity going? And by learning what went wrong to Mars, why it is this, for all intents and purposes, dead planet, whereas Earth is flush with life, we can perhaps understand more about our own future and what's happening to humanity in the future. So by going to space, we learn a lot about what could happen to us.
Okay, so if we go to Venus, we learn about the climate change. We go to Mars and we learn about what happens if you lose your atmosphere.
I like that. I always think of Venus as being Earth's evil twin, and Mars is kind of like this planet which was once like Earth, or had an Earth, most Earth-like planet, I think is the best way to describe it, but we don't know why it ended up so different to Earth.
Just as sort of caution. Going to Mars is not easy. There's a lot of historic, right? I mean, I don't mean personally. That's difficult too. But I mean that very few countries have been able to pull it off. The U.S. and the Soviet Union used to compete to go to Mars. Now, of course, it's farther than going to the moon. It's like 120 times farther at best. But why is it so difficult? Why do so many of the missions to Mars fail?
You try landing a spacecraft on Mars. You've got the distance that the planet is from us, first and foremost. But then you've got the rather confusing aspect that on Earth, we have a really big, thick atmosphere. So when you're trying to land from space, you can have a big parachute that will slow you down. And on the moon, we've got the opposite problem. For all intents and purposes, there is no atmosphere on the moon, so you can use a rocket to land you. But on Mars, we're kind of in this in-between position. So we've got a thin atmosphere on Mars, and that causes lots of problems. So when you want to land something rather big, you need to have a complex system to enable that to happen. So that's why, I don't know if you've heard of the sky crane, which NASA used to land Curiosity on the surface. And we're going to see something similar with Perseverance as well. So Mars is a complex beast.
Let's talk a little bit about the missions. The American mission is the Perseverance Rover. In fact, I think it's February 18th. It's supposed to plop down onto the surface of our little ruddy buddy up there. And you have the rover, and it's also carrying a helicopter, or a drone, I suppose is more accurate. The Perseverance Rover, what's it going to do? What's its mission, sort of in broad strokes? I mean, why are we sending this thing there? Motorized skateboard onto Mars again.
I love that expression, a motorized skateboard. I like to think of Perseverance as being like Curiosity 2.0 because it looks pretty much identical to Curiosity, but it's got better technology because obviously technology has evolved since then. So we're going to see a rover on the surface of Mars, which has its main mission to actually hunt for previous life, signs of life on Mars or signs of microbial life today. And there is also the potential for this mission for Perseverance to actually cache, so to dig up from the surface and cache a sample of Mars, which could potentially be brought back to Earth from a later mission.
It's actually looking for samples to cache, to pile up, like, I don't know, explorers might set up cairns in the Antarctic or the Arctic kind of thing. It's not actually going to look for life itself. It's not going to bring any samples back to Earth. It's doing a reconnaissance mission, right? I mean, haven't we done that before?
We have, but to quote Carl Sagan, extraordinary claims require extraordinary evidence, and we're going to Mars not only to expand humanity into the cosmos, but to answer these really profound questions. And by just sending one rover, having a quick look around, and then never exploring Mars, we're not going to be able to answer those questions. So actually having the sample, there is a potential for a future European mission to actually bring that sample back to Earth. So it's really the next step with the latest technology in terms of trying to answer that question. Piece by piece, we're getting this jigsaw puzzle together to really try and understand more about this red planet and whether it could have had life in the past.
And it's going to a very special place, Jezero Crater. Pretty small crater, actually.
It's about the size of Lake Tahoe.
Yeah, well, okay. But probably the real estate values are not the same. Okay, but why Jezero Crater? I mean, the name's interesting.
Because this is a place which scientists believe was once actually flooded with water in the past. We don't know whether there could be evidence of life there right now. So this is a place which is really interesting. There could be rich deposits in the clay. So it's something which is exciting for scientists to explore and really give us the best chance of beginning to try and answer these fundamental questions.
So it's looking for dead life.
Yeah, or evidence of past life, perhaps even microbial life today.
And to be brought back to Earth, by the way, right? I mean, these things are not going to be examined on Mars. They're going to stow them in some sort of future spacecraft and bring them back to the laboratories here on Earth, right?
Yeah, that's the potential. And imagine having a piece of Mars back on Earth that's been brought back from Mars to Earth just changes everything. And it will just inspire so many people, as well as being able to do a whole new range of science here on Earth.
Yeah, in other words, if we find the Martians, thanks to this effort, we'll find them in a lab here on Earth, not on Mars.
Yeah, it doesn't sound as exciting as that, does it? When you say we might find them in a lab here on Earth, what you want it to be like a big discovery, like humans set foot on the surface of Mars. We gathered up all this evidence, and then they finally find that final clinching piece of evidence to say we are not alone. But the reality is, it's going to be someone in a lab on Earth, and then it's going to be peer reviewed, and it's going to take a long, long time. But it's an extraordinary thing we're trying to discover, and you can't just make claims without backing them up.
Okay, February will also see the arrival of China's Tianwen-1, and it seems to be a lander, an orbiter, a rover, all in one. It's like a Swiss Army knife to Mars. Tianwen-1 is going to be looking at soil characteristics. This is with the rover part, of course, water ice. To what extent do you think that this is about the science and, maybe it's more about the prestige?
I think it's about both with China because obviously they're investing heavily in science and technology. They recognise the national benefits from having great investment in STEM and what that can bring for business and for the country. But a lot of it is also for prestige and the fact that China, you've got to remember, when humans were walking on the moon, China was living under the Mao regime. Many people in China wouldn't have even realized that humans had set foot on the surface of the moon. And now China is bidding to become the third superpower, so to speak, in space.
Well, there's another country, one you wouldn't have thought would be going to Mars, and that's the UAE, United Arab Emirates. They're sending some hardware to the Red Planet as well.
Well, yeah, HOPE is a science mission. So that's the UAE mission. They're going to be studying seasonal weather cycles on Mars and looking at the lower atmosphere. But again, there's this national prestige as well. The UAE, they've had their first astronaut recently. There's really a lot of national pride behind this mission with the UAE. So it's yes, it's contributing to science, but it's also inspiring a nation, inspiring a different type of nation that we too can succeed in space. But none of this is a bad thing because the more people and more nations on board with space, the more we're going to progress as a species beyond Earth.
Well, okay, let's return briefly to the science sort of for a kind of a final wrap-up about all this sort of stuff. I mean, we've discussed finding life on Mars. That would be profound. All right, even if it's only microbial, because unless it was related to us, you could say, okay, life must be all over the cosmos if you find it in, 2 adjacent planets. I mean, that's unusual unless there's a lot of life out there. And if we find that it is related to us, then, who knows? Maybe you have an ancestral castle or something on Mars from your previous incarnation.
I honestly believe you do.
Yeah. Well, good. I hope it's well heated. Okay, so that would be interesting. But suppose we find out, well, there never was life on Mars. There are no Martians now. There never were any Martians. Would Mars still be interesting? What are the big things in the realm of science that Mars could tell us?
First of all, I would say Mars is interesting even if there's no life there because it's really our next step in exploring beyond the Earth. So the moon and then Mars, you really wouldn't want to go to Venus. Mars is the most human-friendly planet, should we say, even though obviously you couldn't live there without a spacesuit. So in terms of just understanding technology and our capabilities to travel beyond Earth and then go to other planets and other moons in our solar system, Mars is really that next step. And even if we don't find life there, just in terms of the engineering and the feat of what humans can do by going there and suddenly no longer being a one-planet species, but a multi-planetary species, that changes everything. Mars is only the next step. We are this one tiny planet, which is part of one average solar system in a universe which is too big to even comprehend. And even if we don't find life on Mars, we've then developed the technology to explore further.
Sarah Cruddas, thanks so very much for speaking with us.
Thank you for having me.
Sarah Cruddas is a space journalist, a broadcaster, and she is the author of Look Up, Why Space is for Everyone and Why It Matters.
Everywhere I go, I'm the first. Step outside the rover, first guy to be there. Climb that hill, first guy to do that. 4.5 billion years, nobody here. And now, me. I'm the first person to be alone on an entire planet.
Well, more firsts coming up. Later, the first helicopter flight on Mars, but before that, what the Emirates Mars Mission means to that country.
Getting from where we were in 1971 required accelerated development. You needed to catch up with the rest of the world really fast and therefore do things unconventionally.
My mom always told me to keep my shoes off the coffee table because it mars the finish.
Have you been holding on to that quip all this time?
I have, yes.
That's another first.
Well, I'm sure it was worth it. It's Mars Attracts on Big Picture Science. It's incredible to be living in this time of escalating space exploration. Seems like we'll have crewed missions heading to Mars before we know it.
Well, there'll be a lot more firsts that need to happen before then, and we will be covering them here on Big Picture Science.
And we'll be doing so thanks to financial support from our listeners. If everyone hearing this just gave a couple of bucks a month, we'd be unconstrained and unrestrained in our quest to bring the latest science happenings to you each week.
And now it's easy to help us at patreon.com/bigpicturescience. It's also quick, secure, and it keeps us in production week after week.
Our Patreon supporters all get at least one extra perk, which is that they don't have to hear these ads every week touting all the other perks Patreon subscribers get.
Such as hearing your name in the credits of the podcast or the opportunity to get Seth's reply to your most confounding science quandaries.
And the most popular prize? Access to exclusive bonus material. You can hear extended interviews, discussions of mysterious phenomena like monoliths or the Galactic Federation, and more. Just go to patreon.com/bigpicturescience and sign up.
Thanks for your support.
Thank you. We're talking about why Mars is poised to be all over the news this month. Let's continue with our own close-up of one of these first ever Mars missions. Meet a scientist who is helping to bring us hope.
Hi, I'm Al-Amiri, and I'm chair of the UAE Space Agency and Minister of State for Advanced Technology.
When the HOPE spacecraft enters Martian orbit this month, its name will reflect not only a wish for greater understanding of the planet's atmosphere, weather, and climate, but also the ambitions of its home country. Her Excellency Sarah Al-Amiri hopes that the mission she is leading will also energize science in the Emirates and make the country a player in space exploration.
And there's good reason to think her aspirations will be realized. Just 7 years ago, the Emirates had no space agency, no planetary scientists, and it had just launched its first satellite. Now the nation is engaged in a mission to another world.
As a nation, if we go back, the Emirates is only 50 years old, very young in comparison to nations in terms of number of years of existence. And it's a very small country with less than 10 million people. And we are more than 200 nationalities coexisting at once. And getting from where we were in 1971 to where we are today in 2021 required accelerated development. You needed to catch up with the rest of the world really fast and therefore do things unconventionally.
So you said you had an accelerated space program. Why develop a space program and why set your sights on Mars in particular?
So the space program development was to develop science and technology capabilities within the country, to transition our economy, to ensure that a lot of our industry is rooted in technological development. And the space program made sense because one, it's aspirational. So it drives a lot of change in society so people can start focusing on science and technological advancements. And that becomes a realm of possibility rather than something that's impossible, something that only a few countries around the world can do. And the other aspect of it is exploration allows us to develop both scientists and engineers at the same time. And why Mars? Because Mars, out of our solar system, is one of the closest resemblances to Earth and allows us to study changes to a planet that is similar to ours. Mm-hmm. And what struck a chord with us as a team is understanding the climate change that happens on Mars to better understand in a larger scale of things how this happens and how this may affect Earth.
So it sounds like you're transitioning, would it be fair to say, from an oil-based economy into maybe a knowledge economy or a science economy? Could one have that?
Absolutely. So the transition is into a knowledge-based economy. Perhaps I shy away from saying a science-based economy because a knowledge-based economy allows for also the creative industry to grow. And we do have a vibrant creative industry growing here. We are an economy based on hydrocarbons and investments from hydrocarbons. And what we're looking at for the next 50 years is investing a lot of that income into the creation of new industries that are deeply rooted in knowledge creation and development. Because you need to sustain your economy moving even post an era where oil demand will decline. And we do understand that will happen.
Let's talk about the orbiter. And the orbiter has a wonderful name. Its name is Hope. And not only is this the first Mars mission for the Emirates, but Hope will produce the first global map of the Martian atmosphere. And what are the big questions that we have about the atmosphere, and how does that relate to climate, which you just mentioned?
So the Emirates Mars Mission has three main objectives that it's studying. First, we have a comprehensive picture of the lower atmosphere of Mars and the weather system that exists within the lower atmosphere. The second, we want to understand hydrogen and oxygen loss, and that gives us an answer to atmospheric loss. And the third one, which is unique to this mission, we want to better understand what role the weather system has in atmospheric loss. So what role does dust storms have on loss of hydrogen and oxygen from the atmosphere of Mars? If you take a step back, it answers to the question of what happened to the atmosphere of Mars and what role did climate change have?
The map is produced of the Martian atmosphere. Is that the same as producing a map of Martian weather? Is that a detail within understanding the atmosphere?
Yes, we actually look at the lower atmosphere of Mars where the weather happens, and we are able to cover everywhere on Mars at all local times so that we have a comprehensive view every roughly 10 days. And this gives us for the first time a holistic view of the Martian weather system. And we do that using our infrared spectrometer, our visible imager, and we also have an ultraviolet band that allows us to have that better understanding of the lower atmosphere.
What kind of atmospheric phenomena do the instruments aboard HOPE allow you to detect?
So those instruments actually allow us to detect clouds, detect carbon dioxide so that we can understand the temperatures, and also allows us to detect the dust, which compromises a phenomenon that we want to better understand, which is the dust storms of Mars. How do they start, and why do they become global, and why do they extend for long periods of time?
Mm-hmm. When you say they become global, they really travel the whole of the planet?
Yes, a dust storm in Mars can start in a local area, and it can cover the entire planet, and it can go on for days. And this is something quite strange to us here on Earth. We don't see dust storms starting in one spot and covering the entire planet and going on for a period of time. We rarely see it happening in a local area and going on for such a long time.
Now, I understand that entering Martian orbit, so you have HOPE, the orbiter, needs to enter Martian orbit. And this is a direct test of what you've planned. And it's my understanding that if you can enter that orbit, that will be a big success, a big win. What makes inserting a craft so challenging?
So the first reason that entering into Mars orbit is challenging is you have no real-time communication. And we basically send a command ahead of time. And the spacecraft needs to execute it. If it runs into trouble, it needs to fix it. And it needs to try its utmost to get into orbit. The second reason is that it burns a lot of fuel for a long time. So 30 minutes, it will burn half of the fuel that it's carrying with it during that period of time. And it needs to dramatically reduce its speed so that it gets into the right speed that would allow it to capture the gravity around Mars and basically start rotating around the planet.
Now, you didn't have to reinvent the wheel to go to Mars. To what extent did you draw on the knowledge of the American space program and work with any American scientists?
So drawing on the knowledge of different programs has been the way that we've moved forward. There's really no point of entering into the space program today without learning from others and continuing on. So this is how we approached it. We looked at what other countries have done and how they've approached it. We found partners that think the same way that we do and have the right objectives. And that's the University of Colorado Boulder alongside Arizona State University, University of California, Berkeley. And we instigated and drove an entire team to start working together.
Although it is still significant, of course, that Emirates is going to Mars, and there must be a lot of national pride around that. It's a big first, and I'm wondering what it means to you personally.
For me, if you asked me a day or two before I started working on this mission in late 2013, if we were ever going to send a spacecraft anywhere outside Earth's orbit, I would have replied with a resounding no way that would have been possible. And to me personally, just going through this journey, for myself, it's been 7 years of my life from we first started thinking about it. It's been an interesting personal growth journey. And you go into an internal appreciation when you're met with such vast challenges as building a space exploration mission. One, there's no end. It's been a continuous roller coaster of worry and ensuring that we've covered everything, and then a little bit of a high celebration. Yes, for example, we achieved a milestone, and then it's again back to hard work in areas which are very risky, which space exploration is more than anything else. There's only so much you can do, and then the rest is left to probability.
You have to let go.
You have to let go.
Do you remember what first captured your imagination about space? And I mean, back perhaps when you were a young girl.
I remember the beautiful images of galaxies. And they're very mesmerizing because of their vastness, one. And two, perhaps the question of how did somebody think about learning about the universe? And why did they think they could image it in various wavelengths to bring all of this information that we have today to light?
How would you have come across your first picture of, say, the Andromeda Galaxy? Where would you have seen it?
I believe it was in a space book that I was reading that I probably purchased. I was an avid reader as a young child. It was just fascinating every time I picked up a book about space. But it was, again, something that I never thought that I could dream or say that, yes, my dream is to work on a mission to Mars. Maybe now that I can think back to it, it triggers wild imagination in children. And perhaps that's what stimulates an entire society when you have a space program. Okay,
well, Sarah, can you paint us a picture of where you will be at that moment when Hope enters the Martian orbit? And I love just saying that. When Hope enters the Martian orbit, where will you be? Give us an image.
I will be with the team, the people that I started working with on this program, the people that I understand what it is to go through such a space program. So I would be happy to celebrate either way with the team.
So will this be a room with lots of computers and those images we have of mission control at NASA where everyone is, well, that was back when everyone would like smoke in the room, but you just see rows and rows of people looking at the computers, biting their nails?
Well, the benefit of us starting a space program right now is we've discarded the rows of computers. You don't need a lot of computers to run a space mission anymore. So we have a very small command room and we have a very small engineering observation room. And I'll be somewhere not distracting them. I'm not part of the team that is operating, and I know they need their concentration, but I'll be in the corridor between the two rooms waiting for our first signal telling us that Hope is in orbit around Mars.
That's lovely. Well, we will be there with you in spirit. You know, one day you may be doing all of this on a laptop in your bedroom. Who knows?
We are. We are.
You actually have.
Yeah. So because of COVID and the pandemic, some of our team members do have the console, at least to observe the spacecraft health on their laptops.
So that brings it right around, doesn't it? Because young people often sit in their bedrooms or under the covers reading the science fiction books late at night, letting their imagination wander. And now you can actually direct those missions that you imagined all those years ago from the same spot.
Yes.
Well, Sarah Al-Amiri, it has been such a pleasure to talk to you as we hope for the very best from this mission. Thank you for speaking with us.
Thank you so much.
Her Excellency, Sarah Al-Amiri, is the United Arab Emirates Minister of State for Advanced Sciences and Science Lead for the Emirates Mars Mission. Hey, if your ears have picked up on the new music in our show, well, those are original pieces from composer Dewey DeLay. We heard that among the questions that the Emirates wants to answer is, what happened to the atmosphere of Mars? And coming up, NASA works with the atmosphere it's got when it attempts to fly the first aircraft on another planet. Now, that's ingenuity.
Our minds and machines turn Marsward. This month, it's Mars Attracts on Big Picture Science.
We've been drawing on the movie The Martian to help give us an idea of the rusty, dusty environment of Mars and how it presents visitors with challenges. Here's a formidable one confronting the fictional astronaut who's stuck on the planet.
You want to send a man into space without the front of his ship?
Well, no. We're going to have him cover it with pab canvas. Look, the hull's mostly there to keep the air in. Mars's atmosphere is so thin, you don't need a lot of streamlining. By the time the ship's going fast enough for air resistance to matter, it'll be high enough that there's practically no air.
You want to send him into space under a tarp?
Yes.
The thin atmosphere of Mars will make it hard for a future astronaut to breathe, but it's also a challenge for visiting machines.
My name is Håvard Grip, and I'm an engineer with NASA's Jet Propulsion Laboratory in Pasadena, California. And I'm the chief pilot of the Ingenuity Mars helicopter. And I also led the development of the helicopter's flight control system.
We are racking up firsts in this month's Mars missions. Another one is NASA's helicopter Ingenuity.
Well, it's the first aircraft that would fly on another planet.
Now, in some ways, the Martian maiden flight checklist sounds routine, familiar to us here on Earth.
Checking that the hardware works as intended, that the weather is suitable for flying, the wind conditions, and then planning where are we going, what altitude are we going to go to, how fast are we going to fly.
But what's not routine? Monitoring a flight 35 million miles away and generating enough lift in the wispy, thin Martian atmosphere. Lift is the force that causes the helicopter to rise and is produced by directing air downwards. That's just the way a propeller sends a ship forward. Except, of course, air is much, much less dense than water, and even more so for Mars, so the props have to spin much faster to move as much air.
Helicopter pilots on Earth will tell you that below 10,000 feet, the air is sufficiently dense to allow them to fly, but if they go much higher, the air just gets too thin. That's why when hikers get into trouble on Mount Everest at 29,000 feet, you cannot send a helicopter to the rescue. So consider this, flying on Mars at more or less ground level is the equivalent to flying at 100,000 feet on Earth.
NASA engineers overcame that problem by design. The Ingenuity helicopter, which is tucked under the belly of the Perseverance Rover until it flies, is a small thing about 15 centimeters in size. Below it are some simple splayed legs that are the landing gear. And above the body, and connected to the motor, are two coaxial propellers rotating in opposite directions. Two, so that the whole helicopter doesn't twist, and both spinning at high speed to compensate for the thin air.
So the blades themselves, of course, they rotate in opposite directions on the two rotors. And in addition, we have the ability to control that pitch angle of the blade, move it up and down in pitch so that it can take bigger or smaller bites out of the air. And that's how we modulate how much lift it produces. And that's how we're able to steer the helicopter.
Which the NASA engineers cannot do in real time. It takes much too long for any control signal to get to Mars. Reminiscent of what Sarah Al-Amiri said about the Hope orbiter. Once you've done your programming, then you have to let it go.
When the actual flight happens, we just have to sit back and wait for word of what's happened, because the helicopter has to do everything on its own during the actual flight.
More about this historic flight and whether the hard-working, serious engineers like Håvard Grip that are behind it are also, as I read they were, quite giddy about it all. Håvard, is that the right way to describe it?
Yes, I think that's absolutely the right adjective. Mixed with, of course, a lot of, anticipation. There's a lot, that's going to happen before we actually fly. But yes, giddiness is definitely part of it.
Well, I wonder if we could put Ingenuity in the context of rover exploration on Mars, or really rover evolution, because up to 1997, the hardware that landed on Mars was stationary, and then wheels appeared in 1997 with Sojourner, followed by the wheeled rovers Spirit and Opportunity, and then Curiosity came along. Now Ingenuity is bringing wings. Håvard, what is the advantage of wings?
So we see, some big potential advantages with having a flying platform on Mars. One thing is that a helicopter, it can traverse fairly large distances over short periods of time, and it's not hindered by terrain the same way that a rover is. So for one thing, it has a potential use as a scout for a future rover. or even potentially for future astronauts, if we send astronauts to Mars, in order to just scout out the terrain, looking for good routes to take or potential science targets. And then we're also looking at concepts for larger helicopters that could potentially take their own science payloads into areas that would be inaccessible on the ground.
Wow. So if we recall that wheels first appeared on Mars in 1997 with the rover Sojourner, that was the first time that a wheeled rover appeared on the planet. Is Ingenuity the aerial component of Sojourner in that it's a maiden voyage?
Yeah, that's an analogy that a lot of people have made. Is Sojourner sort of set the stage for using wheeled vehicles on Mars, and we're hoping that in a similar fashion that Ingenuity will set the stage for future aerial exploration.
So this is the beginning of a new era, perhaps.
That's what we're hoping.
There's that combination of giddiness and caution.
Yeah.
Well, in Håvard, in thinking about how Ingenuity is testing the principles of flight on Mars, I was thinking about the Wright brothers. Now, they also moved from an interest in wheeled vehicles, of course, bicycles, they owned a bicycle repair shop, to solving the problem of flight. Do you see parallels here?
Yeah, I think there are parallels. And in particular, I think there are parallels in terms of what we're trying to do on this mission. We're not going there to perform science with the helicopter. We're going there to just prove that it's possible in the first place to fly a helicopter in the Martian atmosphere. So I think there is an analogy there to the Wright brothers' first flight, which was, not aimed at, building a full-fledged passenger airplane or anything, but rather a technology demonstration, if you will, demonstrating the possibility of flight in the first place.
I have a quote here from John Daly, who is the director of the National Air and Space Museum, which is home to Kitty Hawk, describing the challenge of flight. And I wonder if this is going to sound familiar to you, because he writes, "It looks simple. One small engine, wood, wire, fabric, and even a few bicycle parts, yet nothing was simple about creating the world's first airplane." Håvard, is there anything simple about creating the first Martian helicopter?
No, there really isn't. You could say that, when you just look at the problem, there are certain aspects of it that look relatively straightforward. But then when you get into the details, you discover everything that you have to think about, not just producing enough thrust or enough lift in the Martian atmosphere, but, how is the helicopter going to handle in that thin atmosphere? What issues do you have with vacuum and the temperatures on Mars, for example, and communicating with the helicopter? And the list goes on and on, so there is nothing simple about it.
Let's come back to what you said about atmosphere, because that is really important. Flying machines need atmosphere in order to get that lift. When I read that the Martian atmosphere is 1/100th as dense as Earth's, I think I have that right. That means that there is much thinner atmosphere on Mars. Can you give us a sense for what that feels like, or what that means to have a thinner atmosphere on Mars?
Yeah, so first of all, the atmosphere on Mars consists of different gases than they do on Earth. So it's primarily made up of CO2. And when we talk about it being thin, what we're talking about then is the density. Basically, how many molecules of that gas, do you find in a certain amount of volume? And any kind of aircraft, like a helicopter, has to have a mass to react against. The way that it flies is by mobilizing that air mass downwards in order to react against it and for the helicopter to establish thrust upwards. And the less of that mass that you have to react against, the less thrust you can produce. And what it means for the design is you have to focus on that thrust, design it to leverage the little amount of atmosphere that's there to produce as much thrust as you can. And then you have to try to shrink and miniaturize everything that goes onto the helicopter so that it's light enough that it can work with that limited amount of thrust.
How do you get lift in an atmosphere that is so thin? Because you need those air molecules, don't you, that density in order to lift the aircraft up. So what is the engineering solution you came up with?
So you're right that you do need atmosphere in order to fly. If you had none of it, then you couldn't produce any thrust, and flying with a helicopter would be impossible. And so fortunately on Mars, we do have a little bit of atmosphere, and you just have to maximally leverage that little amount of atmosphere. So in practical terms, what that means is you want to make the rotor as large as you can with the size or the space that you have available. And with that rotor, you want to spin it as fast as you can before you run into issues with speed of sound at the tips. That's sort of your speed limit. And that, fundamentally then will give you a certain amount of thrust to work with. The other part of the problem is then just shrinking everything else on the helicopter, making it as small and lightweight as you can so that it can work with that limited amount of thrust.
Well, I know there's been a lot of trial and error in the development of Ingenuity, just as there were in those early glider experiments and early propelled flight of the Wright brothers at Kitty Hawk. And I saw a video of an early flight attempt of Ingenuity where you had adequate lift, so the helicopter got up off the ground, but you didn't have any control. And I wonder if you could describe for us what happened to the prototype in that case. What would we have seen had we been in the room with you?
Yeah, I know the video that you're referring to, and that was one of our early experiments where we were very much focused on the sort of obvious issue with flying on Mars, which is, well, we don't have very much atmosphere, so producing enough thrust is going to be very hard. And so we have to prove that we can indeed, take off with a helicopter in Martian atmosphere. What we hadn't yet had the time to focus on as much was the controls of the helicopter, figuring out the more subtle details. So how will the helicopter handle in these atmospheric conditions? And someone, in that experiment was trying to use a joystick from outside the chamber in order to maintain control of the vehicle. And as you said, that just wasn't possible.
It would kind of be bouncing around. You'd get it up and then it would come down and bounce, and you get it up again and then it would come down somewhere else and bounce. Yep. That's the loss of control.
Yeah, exactly. It showed that, yes, we can produce thrust, but we have to work on the controls aspect.
And I would assume the ability of a helicopter to hover is why it has an advantage over an airplane or an aircraft on the planet.
Yeah, I mean, one of the advantages is you don't need a runway for takeoff and landing. So that is, one obvious advantage of a helicopter.
I see. Okay, so Ingenuity, this is a test of concept. It won't have, will it have cameras on it then?
Yeah, it actually has two cameras. One of them we use for navigation. We look down on the ground and we track the features of the terrain and how those change in the field of view in order to see how the helicopter moves. And then we have what we call a return to Earth camera, which is a higher resolution color camera that we can take pictures with, and we hope to get some of those downlinked to the ground so we can look at them.
And what will be considered a successful mission of Ingenuity?
A successful mission is flying the helicopter on Mars.
It's that simple. It's that simple and that complicated.
Exactly. Yep.
Well, finally, Håvard, we know how the maiden voyage or the first flights at Kitty Hawk changed the world in terms of human flight. How might this voyage of Ingenuity change space exploration?
Well, as I said, I think there are a lot of benefits potentially to having helicopters for Mars exploration, among them just being more efficient in terms of scouting out terrain for rovers or future potential astronauts, but then also taking science instruments potentially into areas where you couldn't access them via a rover. And so we think it adds that additional dimension and that has a great potential. Well,
Håvard Grip, thank you so much for speaking to us and good luck with the mission.
Thank you so much.
Håvard Grip is an engineer with NASA's Jet Propulsion Laboratory in Pasadena, California, and is the lead engineer of the Ingenuity's flight control system.
Well, Seth, what is the big picture here in terms of the missions to Mars?
Yeah, well, the big picture is we're going to Mars. And Mars is so intriguing. I mean, Buzz Aldrin called the moon magnificent desolation. This is not desolation. Mars has interesting topography. It changes. It has weather. It has an atmosphere. I mean, Mars is where the action is in the solar system, probably more than any other place. And, we're finally going to learn more about its secrets.
Well, some of those secrets include what happened to the Martian atmosphere, and we heard all our guests talk about that. This last interview, the puzzle was, how do you fly a helicopter through that thin atmosphere? But also the Arab world's first Mars probe promises to give us a map of the weather and the climate on Mars, and to try to answer some of those questions about what happened to that early Martian atmosphere that we assume was much thicker when Mars was a wetter world.
Well, it would have had to have been, because otherwise you couldn't have that liquid water on the surface. And there's certainly very good evidence now that Mars did have lakes, maybe oceans, 4 billion years ago. So maybe it had life. And, the big attractant for Mars is and has always being, hundreds of years, the length of time we could actually see Mars as a little ball in a telescope. The big attraction has always been, does it have life? Did it have life? And, I think we're closing in on it.
And as Sarah Cruddas pointed out, that the more that we understand other planets in our solar system, the better we have an understanding of our own planet and the way that it is changing.
Well, true enough. I mean, we look at Venus, we say, this is what happens if you let, climate change get out of hand. And Mars is another problem. This could happen to your planet too, although what happened to Mars is not likely to happen to Earth.
Well, we could not do this show without the out-of-the-world talents of senior producer Gary Niederhoff and assistant producer Sarah Derwin. I am executive producer of Big Picture Science, Molly Bentley.
Thanks also to financial support from Rena Shulsky-David and Sammy David, and to the William K. Bowes Jr. Foundation, and to NASA. Big Picture Science is produced at the SETI Institute, a nonprofit education and research organization that investigates the composition of planets, moons, and asteroids, among other things. I'm the Institute's senior astronomer, Seth Shostak. A big thanks to our listeners and to those who have joined Big Picture Science on Patreon.
Extra thanks to some of our Patreon dolphins, Ken and Joan Claiborne in Elkhart, Indiana, and Jamie Ferns.
As well as Patreon Velociraptor Charlie from Down Under.
Original music was composed by Dewey DeLay. If you'd like to know more about the guests you've heard, well, you'll find links to them on our website, bigpicturescience.org, along with past episodes of Big Picture Science. This episode is called Mars Attracts.